So this is the second part of lesson 2. We're breaking it into 2 parts. So to start with, we're going to make equations and graphs based on this. So the first question says, suppose x and y vary inversely, and that x is 2 and y is negative 3. Okay, so first, to be inverse, my equation for that is x equals k over y, or I could also do y equals k over x, or I could do k equals xy. Those are all technically inverse equations. So here's what I know. I know that x is 2 and y is negative 3, but we know when we write equations, all we care about is what the k value is. So I have to find that first. So step 1 is to find k. Okay, if we're finding k, I would use that equation. So I would say k equals 2 times negative 3, which means that k equals negative 6. So from that, you can make all of the different equations that go with it. So I could say x equals negative 6 over y. I could say y equals negative 6 over x. Or I could say that negative 6 equals xy. Any of those are technically correct. So now I'm going to make a graph of this. So what I know is I know the point 2, negative 3, because that's given to us. So over 2 and down 3. Okay, so then the second part that I want is points that multiply to negative 6, because we know that that's what x times y has to do. So what I know is that 1 times negative 6 will do that. Over 1 and down 6 goes a little bit off your graph. I know that 3 times negative 2 would give me that. And then I also know that 6 times negative 1 would give me that. Okay, so here's the first side of my graph. So now I have to do the opposite side of this. So I have to do other points that give me a negative. So I know that that would be negative 1 times 6. Then I know that I would have negative 2 times 3. I would have negative 3 times positive 2, and I would have negative 6 times positive 1. Okay, so this is the other part of our graph. So this is what an inverse graph looks like. They go in 2 different directions with that. So our next question is, what is y when x equals 5? Okay, so if I'm looking for y, which is what we're doing here, my equation for finding y is y equals k over x. Well, I know what k is, and they told me what my x is, so y equals my k value, which is negative 6, divided by 5. So that means that y equals negative 1.2. So let's go back over to our graph, 5 and down 1.2, and that matches up and makes perfect sense. Okay, so now we have some story problems to go through. A recent hurricane left debris around the neighborhood near a school. The table below shows the time and minutes that would take the group of N students to remove the debris from the average sized yard. So you have a table there. So the number of students would probably be your X value, and this would be your Y value for time, but obviously we're going to use the different variables to go with it. So we need to look at what kind of relationship this is first. So look at your values. As the x's go up from 1 to 3 to 5 to 14, then the time goes down. So I went from 225 down to 16. So as one goes up, the other goes down is going to be inverse. Okay, so we know that our inverse equation is what we want to work with here. So part A says write a function that models the time needed to clear the debris from an average size yard relative to the number of students working on it. So I need to find my k value to begin with. So part 1, again, is finding k. Okay, so I know when I find k, that k is going to be equal to x times y. So I can take any ordered pair here that I want. Well, obviously the easiest one is going to be to do 1 times 225. So I know that k equals 225. Okay, so from here, I can do the equation in terms of students. So 2 is equation for students. So that is my n value. Okay, so I would say that x is equal to 225 over y. You could also say that n is equal to 225 over t if you want to keep those variables the same. And then the third one would be, switch my colors here for you. Third one would be an equation for the time. So that would be y equals 225 over x. Or you could say t equals 225 over n if you're staying with those two. Depends on what you want to do. Okay, part B of this says how many students. So how many students should there be to clear the debris for an average size yard in at most 25 minutes? So I'm looking for students. So that means I'm using my second equation. So I'm using the green equation there. So if I have 25 minutes, I'm going to say x equals 225 divided by 25, and that's going to give me 9. So I need 9 students to do the work in that amount of time. Next one. The average bags of mulch that you need to cover a planted area varies jointly. Okay, so that takes us to a different type of equation. With the area mulched in square feet and the depth in square feet. If you need 10 bags of mulch to do 120 feet in depth and 3 inches, how many bags do you need? Okay, so first is my variables. So B is going to be bags, A is going to be area, and the area, and then D is going to be depth. Such a bad problem. Ha, math joke. Okay, so then I need to convert. All right, so in converting this, I know that the depth is 3 inches. Well, I'm working everything else in terms of feet. So I need to say 3 out of 12, because there's 12 inches in a foot, is going to give me 1/4 of a foot. So that's important. So now my equation for this is going to be, because it is joint, that's z equals k times x times y. So that's going to be bags equals k times area times depth. So then I can plug in what I know. I know that I have 10 bags and that my k value times 120 times 1/4. Okay, so that's going to give me 10 equals k times 30. So my k value is equal to 1/3. So that gives me my k value. Now with the k value, I go back and put it into the next equation to actually solve for what it's asking for. It's asking for how many bags do you need to mulch 200 feet. So if I'm going to mulch 200 feet of this, I'm going to plug this back in. So bags is going to be equal to 1/3 times 200 times 1/3. Again, because that's my k, my x, and my y, or my area and my depth. Okay, so then I'm going to put these together and get 1/9 times 200, or I'm just dividing it by 9. So that means I need 22.2 bags, which really means I need 23 bags. Next one. If z varies jointly with x and y. So first, let's go ahead and write our equation. Z varies jointly, so k times x times y. So here's what you know. Then x equals 3 and y equals 5. And z equals 120. So you have 3 parts, so I can fill that in. 120 equals k times 3 times 5. So 120 equals k times 15. Divide that 15 to the other side, and my k value then is going to be 8. Okay, so now it wants to know what happens when I put different values in, when I put these in. So the same equation is working, but right now I know that my z value is 35, my k value is 8 because we just solved for that. I'm looking for x, and my y is 7. So I have 35 equals 56x divided by 56. And I get 0.625 equals x. Next equation, same sort of thing. Y varies inversely with the square of x. So to vary inversely, I first need my equation. So I need to say that y equals k over x squared. And then I need to plug in as much as I know. So what I know in the first one is x is 3 and y is 7 over 15 equals k over 3 squared. So 7 equals 15 over k times 9. So I can solve this like a proportion or just multiply this to the other side.